This is the first topic in AP Chemistry, so we're going to go over moles and molar mass. We're going to talk about the mole concept and this connection between mass and the number of particles. We're also going to demonstrate the calculation of molar mass. If you're a textbook person, go ahead and look at pages 72 to 79. This will go into the information that we're going to talk about on these slides. So some students kind of struggle with this idea of a mole and what is it. So on this slide, we have an example of sucrose, sodium chloride, carbon, and copper sulfate. And if you'll notice on the electric balance, the mass of each of these substances is different, but each of them is going to contain exactly 6.02 times 10 to the 23rd particles. And so this is Avogadro's number. We're going to go much more in depth in a little bit, but while the samples all contain that same number of particles, the mass of each sample is different. And so why is this? Well, it's because the constituent particles in each sample are different. So a mole is basically going to describe the amount of a substance. So it's basically essentially like a counting number. So sometimes we're going to say a dozen eggs, and so a dozen is always going to mean there's 12. Okay, this is the same way that 1 mole always means that there's 6.02 times 10 to the 23rd atoms. So now the question becomes, how does this relate to mass? So how does the mole concept relate to mass? Well, if I wanted to measure out 6.022 times 10 to the 23rd iron atoms, how much are you going to measure out? And this is where your periodic table is going to become your best friend. You're always going to want to have your periodic table out, and you're going to want to become very familiar with it. I'm not going to make you memorize anything on it because you're always going to have access to it, but you need to be able to read it. So on the periodic table, the number below the chemical name or the symbol is the atom's molar mass. 1 mole of iron atoms weighs 55.85 grams. So if you wanted 1 mole of iron, you're going to measure out 55.85 grams, which is going to be equivalent to 6.022 times 10 to the 23rd iron atoms. And that's kind of how everything is related. So let's go ahead and look back at our examples, and again we have our different substances and we have the different masses on the electronic balances, and so the mass of each of these samples is going to be equal to the formula mass of the substance's particles in units of grams, and this happens to be 6.022 times 10 to the 23rd particles for each substance. And this is going to be the mass of 1 mole, and so that's called the molar mass. And one thing that you need to know about the molar mass is the units. And so the molar mass in units is going to be equal to grams over moles. And so you're going to need to use this molar mass to either convert it into grams or moles based on what the question is asking you to do. So it's super important that you know the molar mass, the units, are grams over moles. So you can solve for either grams or moles at a future date. Now here's where the periodic table comes into play. So the periodic table is going to give you the average atomic mass. So if you look at the periodic table and you find, let's say, magnesium, and so magnesium, the molar mass of magnesium is 24.30 grams, and so the molar mass, you're going to have 24.30 grams for every 1 mole of magnesium, and you can use that to do any of your conversions between moles and grams that you're going to need to use. And also particles once we get into that as well. So now let's go ahead and do an example of calculating molecular mass, and we're going to use sucrose as an example because sucrose is a little bit more of a complex molecule than, let's say, water. And so the chemical formula for sucrose is C12H22O11. And the first step in these problems is going to be to count the atoms in the chemical formula. And so for this, what we're going to do is we're going to look at each of the subscripts that are next to our symbols for each of the elements. And so for our carbon, we are going to have 12 carbon atoms. For our hydrogen, we have 22 hydrogen atoms, and for our oxygen, we have 11 oxygen atoms. And so what we have to do is we have to take this into account when we're trying to figure out the mass of the entire molecule. The next step is going to be to find the atomic mass of each of the elements on the periodic table. And so this is when you're going to have your periodic tables out next to you when you're doing these problems. And so if you were to look at the periodic table, you're going to find that carbon has a molar mass of 12.01 grams per mole. Hydrogen has a molar mass of 1.01 grams per mole. And oxygen has a molar mass of 16.00 grams per mole. Now, you're going to have some periodic tables that have a little slightly different numbers. They round to a different decimal place. That's fine. As long as you're close when you're doing problems for me, the AP exam will give you the periodic table to use, and so you're going to want to use what's on the periodic table that they give you. I'm also going to give you the same one that the AP exam uses, so if you just want to always use that one, you can. The next step, okay, step 3, is that you're going to multiply the atoms by the atomic mass to find the mass per element. And I want you to kind of keep this separate because it's going to be important when we're doing like percentages and the percentage of carbon in this molecule, for example. And so make sure that you're always finding these separate first, and then you guys can sum the results in step 4. So for carbon, we're going to take how much carbon, the molar mass of carbon, so that's 12.01, and then we have to multiply it by how many atoms of carbon there are, which there are 12. And so that's going to leave us, if we multiply that out, to 144.12 mass units. And I'm just going to label that as a U. For hydrogen, okay, again, we're going to take the 1.01 and we're going to multiply it by how many atoms of hydrogen there are, which there are 22. And when we multiply that out, we are going to get 22.22. Again, I'm just going to put the U for our units. And then oxygen, we do the same thing. So oxygen, its molar mass is 16.00 times the amount of oxygen atoms we have, which is 11. And that is going to give us a 176.00. The last step in this is just to sum the results to find the total formula mass. So we're going to go 144.12 plus 22.22 plus 176.00, and we get a total of 342.3 for our formula mass units. Okay, we could also label this as 342.3 grams per mole. Okay, it just depends on what the question is asking you in terms of what units you're going to use. So here's another example. What I want you guys to do is go ahead and pause the video, see if you can work this example out on your own, and then go ahead and check, see if you got all the steps right. So step 1, again, making sure that you know how many of each type of atom that you have. So in H2SO4, we are going to have 2 hydrogens, 1 sulfur, and 4 oxygens. So I'm going to go ahead and write that over here, 2 hydrogens, 1 sulfur, and 4 oxygens. Okay, and again, I'm going to go ahead and look at my periodic table, and I'm going to go ahead and write the information that I need, again, off to the side. For hydrogen, my atomic mass is 0.01. For sulfur, it's going to be 32.06. And for oxygen, it's going to be 16.00. Again, some students are confused where I got these numbers from at the beginning. These are from the periodic table, so I didn't memorize them. I didn't kind of just pull them magically out of thin air. They are from the periodic table, so go ahead and make sure that you have your periodic table out when you're doing these problems. Now all you're just going to have to do is multiply the number of atoms that you have, which I wrote down here, by your formula mass or your atomic mass, and so I'm going to multiply 1.01 by 2 and get 2.02. I'm going to multiply 32.06 by 1 and it's going to stay 32.06, and I'm going to multiply out 16.00 times 4, and that's going to give me 64.00. Now to find the molar mass, I'm going to go ahead and add all those up together to get 98.08 grams per mole. Now notice how it's asking for our molar mass in this question, and so that's why I used grams per mole as my units. Again, here's another example. If you need more practice, make sure that you're going ahead and pausing the video and trying to solve it on your own first, and then you guys can go ahead and look through the steps that I took to solve the problem. Step 1 is, again, writing down your atoms and making sure you know how many of each there are. Now this one's a little bit more complex because we're dealing with a subscript outside of a parentheses. So let's see if you remember from general chemistry, if you remember how to kind of distribute that 3. So what you're going to do is you have 1 Al, okay, and then this 3 is going to get distributed to the oxygen, but it also gets distributed to the nitrogen, just like you would in math. And so that leads us to having 3 nitrogen atoms, and it's 3 times 3 oxygen atoms. So we have 9 total oxygen atoms. So make sure you pause here if you got those wrong, to really understand how you would go about distributing the subscripts outside of the parentheses. Next step is looking at your periodic table and looking at the molar masses of each of the elements. So aluminum is 26.98, nitrogen is 14.01, and oxygen is going to be 16.00 again. You multiply by the amount of atoms you have, and that is going to lead you to 26.98 for your aluminum, 42.03 for nitrogen, and 144.0 for oxygen. You add them all up, and you should get 213.01 grams per mole. Again, make sure that you write your units down. If you don't, you will not get credit. So units are going to be super important throughout the class. So now, how can we use this to convert between moles and grams? So what we can do is use this molar mass. If we don't know the amount of moles, or we don't know the amount of grams, as long as we have the molar mass and one of the other one, we could find the one that we're missing. So what is the mathematical relationship between moles and mass for carbon? Well, basically, it's going to be a conversion factor. And so for every 1 mole of carbon, we're going to have 12.0 grams of carbon. Okay, and so we could use that as a conversion factor. Okay, we could also say that for every 12 grams of carbon, we have 1 mole of carbon. Let's go ahead and put the C there so we know what element we're looking at. And so these are going to be your conversion factors that you're going to use to convert molar mass into either moles or grams, depending on what you're trying to find. Now make sure that you write your units on these, because those are going to be important and helpful in figuring out what's going to go on the top and what's going to go on the bottom of these conversion factors. So then what's the mathematical relationship between moles and mass for sodium chloride? So for this, what we have to do is we would have to kind of add the sodium and the chloride together, which is conveniently going to be right here in our example. And so for every 1 mole of sodium chloride we're going to have 58.4 grams of it. And again, conversion factors can be flipped because they are equivalent to 1. And so it doesn't matter what goes on the top or the bottom, they are always going to be equal. So .4 grams of NaCl goes on top, and 1 mole of NaCl goes on bottom, depending on how you want to use it. So the last slide, I used this idea of a conversion factor. So basically, it's just going to be a ratio, which represents the relationship between the same quantity and two different units. There's going to be two possible conversion factors for every equality. And so you could use grams to moles or moles to grams, just like I showed you on the previous slide. When you're using conversion factors, you're going to want to make sure that you're lining up those units. So basically, if you're multiplying by conversion factor, you're going to have the starting units in the denominator of the conversion factor. And this is going to make a lot more sense when we go ahead and do an example on the next slide. So here's our moles to mass example. So in this one, we're going to start off with moles, and they're going to ask us to find grams. So a chemical reaction consumes 0.85 moles of carbon. What mass of carbon is consumed in the reaction? So what you're going to do to start these problems is you're always going to write with what you start with, what's given in the problem. And in our case, what's given in the problem is the amount of moles. So we're going to go ahead and write the amount of moles starting out. So 0.85 moles of carbon. And again, always write your units. And then what I'm going to do is I'm going to do a little bracket. This bracket's just going to create a multiplication problem for me. You don't have to write it like this, but this is the way I've always found it to be much easier to kind of set up. And so what I'm going to do is I want to convert moles into grams. And in order to do that, I'm going to need the molar mass, because remember, molar mass is grams per mole, right? And so what is on the top here is what I want to have on the bottom on this side, so I can cancel it out, because I can cancel out the numerator and the denominator units. And so I'm going to have 1 mole of carbon down here, and for every 1 mole of carbon, I have 12.0 grams of carbon. Again, that's from the molar mass on the periodic table. What this allows me to do is this allows me to cancel out moles of carbon from the top and the bottom, because if you have something on the top and on the bottom, they cancel each other out. And so then this leaves me with the units of grams of carbon, and I double check. It says, what's the mass? I know mass is going to be in grams, and so that's what I want to end up with. I know I set it up correctly. And when you go ahead and multiply this out, you're going to get left with 10.2 grams of carbon for your final answer. And so that's how you would convert moles to mass. You can do it opposite too. They could have given you grams and asked you to convert it into moles. So now this problem is the exact opposite of the one that we just did. It's asking us to convert grams into moles. So a sucrose packet contains 4.0 grams of sucrose, and if you recall from the beginning of the lecture, C12H22O11 is the chemical formula for sucrose. How many moles of sucrose does the packet contain? If you remember from the beginning of the lecture, the molar mass of sucrose was 342.3 grams per mole. Okay, so I'm not going to go into how we calculated that because we did it before. So now let's go ahead and start the problem. So the problem gives us 4.0 grams of sucrose. So we always start with what we are given in the problem. And again, make sure you write your units. You're going to do your bracket. Okay, and again, if we have grams of sucrose on top, we're going to want to cancel it out with grams of sucrose on the bottom. So I'm going to write my 342.3 grams of sucrose on the bottom for every 1 mole of sucrose goes on the top. And again, we can flip this conversion factor however we need to. I'm going to cancel out my grams of sucrose just to make sure that I'm ending up with the right units. It's asking us for moles. Okay, I'm only left with moles in my units for my answer, and so I know I set it up correctly. I'm going to go ahead and use my calculator to multiply that out and divide. So I got 4.0 times 1 divided by 342.3. And that's going to leave me with 0.012 moles of sucrose, which is C12H22O11. And that would be your final answer. So now let's go ahead and throw one more thing into the mix, and that's number of atoms. I've already mentioned Avogadro's number at the beginning of the lecture. And so Avogadro's number is 6.022140076 times 10 to the 23rd. It's a really, really big number. We simplify it by using 6.022 times 10 to the 23rd. And again, this is just a number that tells us how many atoms are in 1 mole of a substance. It's the exact same thing as me saying a dozen is 12. And it's used to tell us how many atoms are in exactly 1 mole of a substance, and it's always going to be the same. Now, you don't have to necessarily memorize Avogadro's number. It's going to be on your equation sheet, but it's going to be something that you're going to naturally memorize over time after using it so often, but you need to know when to use it. If you don't memorize the number itself, that's fine, but you need to know when to use it. And so let's go ahead and look at an example problem. So we have a diamond, and a diamond in its natural form is just pure carbon. And so the question is asking us what number of atoms of carbon are in a 1.00 carat diamond. And it gives us an additional information that 1 carat is equal to 0.200 grams. So now this is a type of question that AP likes to ask a lot because it throws at you something that you might not be familiar with in 1 carat. And so it's asking you to really understand how to use dimensional analysis in order to find the answer. So you have to understand a dimensional analysis in order to apply it to something that maybe you're a little bit more unfamiliar with. So let's go ahead and work this problem out and see how we would go about it. So first off, we would have to figure out what the question is actually giving us. And so the only number that we're given is 1.00 carat, and we're not used to carats, and so we know we're going to have to convert that to something. Well, it tells us that carats are equivalent to grams, and so what we can do is we can convert that original 1.00 carat into grams first to figure out how many grams of diamond we're starting off with. So the way that I'm going to set it up is I have 1.00 carat, and I'm going to make my brackets, and I know that 1 carat is going to be equal to 0.200 grams, and so I can set my conversion factor up like that. Now notice, I knew I was going to have carat on the bottom of the conversion factor because I had carat on the top already, and so I'm going to go ahead and cancel those out as I go so that I know I'm ending up with what I want. And so it's asking us what number of atoms. So I want to end up with atoms. So I'm not there yet. So I have grams, and grams are not what I want. Now, can I go straight from grams to atoms? And the answer is no. I can go from moles to atoms, but I can't go from grams. So what I'm going to have to do is I'm going to have to convert the amount of grams into moles. So now I know that from my periodic table, for every 12.01 grams of carbon, I have 1 mole of carbon. And again, I'm going to go ahead and cancel out my grams because I know they cancel out. Again, I have grams on top, so I wanted grams on bottom of my conversion factor. So now I'm left with moles, but again, that's not what the question asks. The question wants atoms. And so I know that the definition of Avogadro's number is that for every 1 mole of anything, I'm going to have 6.022 times 10 to the 23rd atoms. And so when you type this into your calculator, basically what you do is the whole, in a straight line, okay, top or bottom, you're multiplying. So these are multiplication. Okay, and a lot of students forget you have to multiply the bottom too. Most of the cases it's only one number, so you don't really have to multiply it because you're multiplying it by 1. But if there are multiple numbers, you do need to multiply those out. And then you just divide the top divided by the bottom. And I'm going to cancel out my moles. I'm going to make sure that all my units cancel out so I know that I set it up right. I'm going to end up with atoms, which I wanted. And if you multiply all of this out, you're actually going to end up with 1.00 times 10 to the 22 atoms. Okay, now if you need a review of scientific notation, let me know and I will gladly help you out with that, but I'm not going to spend time during class talking about science. So here's kind of a summary slide of what we went over. And so basically you can use the molar mass to convert from grams to moles or from moles to grams. You can use Avogadro's number to convert from moles to particles and from particles to moles. You might see it said particles, you might see it said as atoms. Okay, you need to know those are the same thing. Then you can also use both the molar mass and Avogadro's number to convert from grams to particles or atoms and from particles or atoms to grams. And I thought that this kind of picture off to the side did a really good job of visually summarizing how you're going to go about converting to all of these things.